Okay, welcome back. So we'll finish off some more of this U substitution integration. So we've got let u equal 3 minus x squared and so du dx is equal to minus 2x squared minus 2x. So we do our multiplication and division. So we'll get minus 1/2 du, and that is equal to x dx. So just writing this in a way that's a bit more visible, we can do our x on the numerator, the x outside well and truly so we can see that. And then we have 3 minus x squared so we have x dx. Are you there? Yes you are. Dx, are you there? Yes you are. So we get du minus 1/2 the integral of, now they've been subbed out, we're just left with 1 over u. 1 over u, of course, integrated is the ln, so we get minus 1/2 the ln of u, which itself was 3 minus x squared. 3 minus x squared plus c. Okay, very straightforward. And if we check that in something like Wrk1, it will confirm for us that is in fact what we have. Okay, so we have minus 1/2 ln 3 minus x squared plus a constant. So very good. Alright, the next one is the exponential form. These are the ones that we love the most, I think, the ones that we're most interested in. So the exponential integration, we've been through this before, so we're familiar with this. So we let u equal 3x plus 2 and we're looking to stay in the column. Don't run off and change this. Stay in the column, and so we'll get u dx using Leibniz notation is 3. So by the time we do some 1/3 du is equal to dx. So are you there? Yep, there you are. So off you go. You can be exchanged for 1/3 du. Of course, it's e to the u, isn't it? E to the u. So the integral of e to the u is just e to the u. So we end up with 1/3 e to the u plus c. If we normalise that, we'll get 1/3 e to the 3x plus 2 plus capital C. It's our final part. Very good. So pulling these together is pretty straightforward, isn't it, once you get the hang of it. Right, this can be rewritten with a negative index, either minus 5x dx. We can let u equal minus 5x. So du dx is equal to minus 5. So minus 1/5 u is equal to, so are you there? Yep, there you are. So you can be replaced by minus 1/5 the integral du, and we're left with e to the u. So e to the u is equal to, so that integral is equal to, I might just rub that comma out, e to the integral of e to the u is e to the u, and u itself was minus 5x plus c. Now if you want to put that down the bottom, there's no problem with you doing that. That's your final result. So very, very straightforward. All right, now we do get harder ones, of course. And the harder ones are based around gymnastics. They're not based around doing what we think are calculus. So here we've got a quotient. We can look to see if the derivative is on the numerator, and it's clearly not in that form. But this is the result of adding fractions. So the result of adding fractions is that we have a typical adding fractions problem. This is not a calculus problem and won't present itself as a calculus problem. It will present itself as a gymnastics problem. So if we're going to make a product of the denominator, and we'll have a family of the product of the denominator, then we had to multiply by 1 in disguise, and so 1 in disguise, top and bottom. Then we had b minus a, and then so what we ended up with is a numerator that is the result of adding fractions with a family. Now this is what we've got here. E to the 2x is the result of adding fractions. So what we can do is go back a step. We can go back a step and separate or split the fraction. So if we split the fraction, we will have 5e to the 6x over e to the 2x minus, now that's the previous step, 2e to the 4x over e to the 2x. Now this is fractions. This has got nothing to do with calculus. This is just adding and subtracting fractions, and now it's gymnastics. It's the gymnastics of algebra. So these are different. These are apples together, and these are apples together, but they're requiring us to think about how we split them. So if you're not sure of that, go to Wolfram Alpha and check it yourself. You must be able to do this, okay? So in this case here, 5, we're not doing the integration, we're just looking at algebra. 5e to the power 6x okay, divided by e to the power 2x. Let's just see what that looks like. It might not come out quite the way I want it to, but that's all right. No, it hasn't quite done that, so I've got to put it up as tellable from that it needs to be a quotient. And I can do the same there. An equation here. And I can press go. So that's what we want. Now look at this. This has done 6 apples minus 2 apples. 6 apples minus 2 apples is 4 apples. I'm not worried about the graphs. I just wanted to sort out the algebra. 6 apples minus 2 apples is 4 apples. And the 5 remains. So we can rewrite this yet again as a simplified version. We haven't done any calculus there yet. With the 5 still there, 6 apples minus 2 apples. So e to the 6x minus 2x minus 2 e to the 4x minus 2x dx. That's a bit big, so we'll shrink it down a little bit. Okay, so this is not terribly difficult. Okay, so our next one is the integral of 5. 6 apples minus 2 apples is 4 apples. Okay, and 2 the 4 oranges minus 2 oranges is 2 oranges. Okay, dx. Okay, so there we go. 2x. So now we're in a point where we can do a solution. Now if we integrate the individual terms, it might make it a little bit easier for us to manage as we go along. dx. You don't have to do this, of course, but I'm exposing you to it so that you have a sense that you can take these terms and you can make them separate integrations, if that makes the next step easier. Because basically we've got to do a u substitution. Okay? A final one would be, we could take the constants out and really just be integrating e to the 4x when the 5 will still be there at the end. Okay? Minus, take the 2 out, the integral, e to the 2x. Now we can't do anything with the, because they're not apples and oranges. Okay, now that's that bit. So if you're not sure, put it into Wolfram and recall it. Okay? There's nothing wrong with you checking things. 5e to the 4x minus 2e to the 2x. 5e to the 4x. So let's just fix those up. 5e to the 4x. Take that bracket away. Minus e, that away. 2, it was, wasn't it? 2e to the 2x, I think that's right. Just take that last bracket away. Let's have a look at what that looks like in terms of whether it's a match for this bit. 5e to the 2x minus 2e to the 2x. Now look, it's not taking them oranges and oranges. It's not breaking the log rule. Okay? It's just not doing that because it's recognizing that e to the 4x is an apple and e to the 2x is an orange. Okay? So even if we do something like, simplify, it's still not going to break the rule of the algebra of apples and oranges. Okay? It's taken out a common factor, yes, but it just hasn't added them together willy-nilly. So this one down here, you can't just be aware. Okay? Just be aware that you can't just go ahead and do any old thing. Okay? You can't just do any old thing. You've got to obey the rules of algebra. All right. So now that we've got it to there, really we're just trying to find we want to integrate e to the 4x. So that requires us to use a u substitution. Let u equal 4x. Stay in the column. So 1/4 du is equal to the x. Are you up there? Yep. So you're now gone. So we've got du. We've got a 5 out the front anyway. Now we've got 1/4, so we'll just put it like that. And e to the u. So now we've got the integral of e to the u. Well, we know what that is. E to the u plus c 5/4. And we'll do the other one. Let u or m equal 2x. Dm dx is equal to 2. So we've got 1/2 dm is equal to dx. Are you up there? Yep. Right, well, you're gone. So you're gone by minus 2 integral du. That's the substitution. And we've also got a half. So now that's just become minus 1. That 2 was that 2. That half was that half. So that's now just minus 1. Oh, don't forget your e to the u. So the integral of e to the u is going to be minus e to the u plus c, which is minus e to the 2x. Now we'll put the c's together. You don't need to name them c1, c2. Okay, so our integral is going to be equal to 5/4 e to the 4x minus e to the 2x, and we don't need to have c1 and c2, we can just say capital C. Okay, and that's your final result. So these are, important things to deal with. All right, I'll come back soon and we'll do another one. See you soon.